strong, suggestive evidence that humans were traversing the continents and the oceans thousands of years before we were taught in school, which is evidence of being more advanced than we were taught in school.
Right.
Deep in Lebanon's Bekaa Valley, there's a place that challenges what we think we know about ancient engineering. Every year, thousands of tourists visit the ruins of Baalbek to see what remains of one of the Roman Empire's most ambitious temple complexes. They photograph the towering columns, walk through the ancient courtyards, and admire the craftsmanship of classical architecture. Most leave with the impression that they've witnessed another example of Roman engineering excellence, similar to the Colosseum or the aqueducts that still dot the European landscape.
Like when you mentioned the pronouns in their profile,
Yeah.
almost all of them have it and they're not trans. And if you look at their political ideologies, it is extremely left. And these people are visceral, they're toxic. And let me just make a side point that I almost forgot.
What very few of these visitors realize is that beneath their feet lies something far more puzzling than anything the Romans are known to have built. Hidden under layers of Roman construction sits a foundation made from stones so massive and precisely placed that modern engineers struggle to explain how they got there. These aren't your typical building blocks. We're talking about individual stones that weigh as much as several hundred modern cars combined, fitted together with a level of precision that would be impressive even with today's technology. The foundation at Baalbek contains what archaeologists call the trilithon, a series of 3 enormous limestone blocks that form part of the western wall of the temple complex. Each of these blocks measures approximately 19 meters long, over 4 meters high, and nearly 4 meters deep. To put that into perspective, imagine a stone block roughly the length of 2 shipping containers placed end to end, and just as tall as a single-story building. According to measurements taken by researchers from the German Archaeological Institute, each of these blocks weighs somewhere between 800 and 1,000 metric tons. That weight is difficult to comprehend without comparison. The largest stones used in constructing the Great Pyramid of Giza weigh around 80 tons. The famous sarsen stones at Stonehenge, which have fascinated people for centuries, weigh approximately 25 tons each. The trilithon blocks at Baalbek are roughly 10 times heavier than the pyramid stones and 40 times heavier than those at Stonehenge. And here's what makes this even more remarkable. These stones aren't simply resting on the ground. They were somehow lifted approximately 7 meters into the air and positioned with extraordinary accuracy to form part of a retaining wall. The precision of the stonework is what really catches the attention of engineers and architects who visit the site. The joints between these massive blocks are so tight that it's virtually impossible to slide a piece of paper between them. There's no mortar holding them together, no filler material of any kind. It's just stone against stone, fitted with tolerances that modern construction workers would be proud to achieve. Dr. Jean-Pierre Adam, a French archaeologist who spent several years documenting Roman construction techniques throughout the Mediterranean, examined the Baalbek foundation and noted that it didn't match the typical characteristics of Roman stonework he'd encountered elsewhere. What makes this situation particularly intriguing is the question of necessity. When you look at Roman construction projects across their vast empire, from Spain to Syria, you see a civilization that was remarkably practical in their engineering choices. They built to last, certainly, but they also built with efficiency in mind. Roman engineers calculated the loads their structures needed to bear and designed foundations accordingly. A temple, even a grand one dedicated to Jupiter, doesn't require foundation stones that weigh 1,000 tons each. There's simply no structural reason for it. Consider the Pantheon in Rome, one of the architectural masterpieces of the ancient world, with its massive concrete dome that still stands today. Its foundation, while substantial, uses nothing remotely approaching the scale of what we see at Baalbek. The same goes for the Colosseum, which hosted 50,000 spectators and required foundations strong enough to support a 4-story structure. Yet the largest foundation stones there are measured in tons, not hundreds of tons. When Roman engineers needed to support significant weight, they had well-established methods that worked perfectly well. So why would they suddenly change their entire approach for this one temple complex? The Roman Empire was exceptionally good at documentation. They carved inscriptions on their buildings, detailing who commissioned them, when they were built, and often how they were constructed. We know that Emperor Hadrian rebuilt the Pantheon around 126 AD because he told us so, right there on the building's facade. We know exactly which emperors commissioned various aqueducts, bridges, and public buildings throughout the empire. Roman engineers took pride in their work, and they wanted everyone to know about their achievements. This wasn't modesty, it was empire-wide policy to showcase Roman engineering prowess. Yet when it comes to the megalithic foundation at Baalbek, there's a conspicuous absence of any Roman documentation claiming credit for its construction. No inscriptions boasting about moving 1,000-ton stones. No records in Roman engineering treatises describing the techniques used. No emperors taking credit for what would have been by far the most impressive engineering achievement in Roman history. The silence is striking, especially given how much documentation exists for less impressive Roman construction projects. The Roman structures at Baalbek that are documented include the Temple of Jupiter, which was indeed a massive undertaking. Historical records indicate that construction began during the reign of Augustus and continued for decades. The temple featured 54 enormous columns, each standing 22 meters tall. These were impressive by any standard, representing classical Roman architecture at its most ambitious. But these temples were built on top of the existing megalithic platform, not as part of creating it. This raises some uncomfortable questions that researchers have been debating for decades. If the Romans didn't build this foundation, then who did? And when? The weathering patterns on the massive foundation stones show signs of exposure to the elements that span a much longer period than the Roman structures sitting on top of them. This has led some archaeologists to suggest that the platform might predate the Roman presence in the region by centuries, possibly even millennia. The Bekaa Valley, where Baalbek sits, has been inhabited for thousands of years. Archaeological evidence shows human activity at the site going back at least 9,000 years, long before the first Roman soldiers arrived in what they called Syria Phoenicia. The location was considered sacred by multiple cultures. The Phoenicians knew it as Baalbek, naming it after their god Baal. When the Greeks arrived, they called it Heliopolis, the city of the sun. The Romans, following their usual practice of adopting and adapting local religious sites, built their temple complex dedicated to Jupiter. But perhaps each of these civilizations recognized something about this location that drew them there. Perhaps they all built upon something that was already ancient when they arrived. The foundation itself might be a remnant from a culture whose engineering capabilities we don't fully understand, simply because we haven't found enough evidence of them elsewhere. This isn't as far-fetched as it might sound. History is full of examples of lost techniques and forgotten knowledge. The Romans themselves couldn't replicate the earthquake-resistant construction methods used in much older Mycenaean palaces. Medieval European builders couldn't recreate the waterproof concrete the Romans had used for their harbour installations. What we're left with at Baalbek is a foundation that seems to exist outside our normal understanding of ancient construction capabilities. It's not that ancient peoples weren't capable of impressive engineering, they clearly were, but this particular site pushes the boundaries of what we thought possible, given the tools and techniques that were supposedly available. And that's what makes it one of the most intriguing archaeological mysteries in the world. It's not speculation or theory, it's a physical reality that anyone can visit, measure, and verify. The stones are there, impossibly large and precisely fitted, waiting for an explanation that fully accounts for their existence. The Romans arrived at the site we now call Baalbek around 15 BC during the reign of Emperor Augustus. They were in the process of consolidating their control over the eastern Mediterranean, and this location in the Bekaa Valley became an important regional centre. The Romans renamed it Heliopolis, continuing the Greek tradition of associating the site with sun worship, and they set about transforming it into one of their most spectacular temple complexes outside of Rome itself. The construction of the Roman temples at Baalbek was a multi-generational project. The Temple of Jupiter, the centerpiece of the complex, took decades to complete. When finished, it featured 54 massive Corinthian columns, each standing 22 meters tall and weighing approximately 45 tons. These columns were quarried from Egyptian granite and transported hundreds of kilometers to reach the site. The temple compound also included a Temple of Bacchus, which is actually better preserved today, and a smaller circular temple of Venus. The architectural details are purely Roman in style, featuring the intricate carved friezes, elaborate capitals, and grand proportions that characterized imperial architecture during the height of Roman power. There's no question that the Romans built impressive structures at Baalbek. The engineering required to transport and erect those enormous columns was substantial. Roman engineers had developed sophisticated techniques for moving heavy loads, using combinations of cranes, pulleys, and human labor. They documented these methods in engineering treatises, some of which survive to this day. Vitruvius, a Roman architect and engineer who lived during the 1st century BC, wrote extensively about construction techniques, including detailed descriptions of the machinery used to lift and position heavy stones. This is what makes the situation at Baalbek so peculiar. The Romans were meticulous record keepers when it came to their construction projects. Throughout the empire, from Britain to North Africa to the Middle East, Roman buildings bear inscriptions detailing their construction. These inscriptions typically identified the emperor who commissioned the work, the governor or official who oversaw it, and often the specific military units or work crews involved. Some inscriptions even included dates that allow modernity historians to pinpoint exactly when construction occurred. The Colosseum in Rome, for instance, has clear documentation showing it was commissioned by Emperor Vespasian around 70 AD and completed by his son Titus about a decade later. We know that specific legions were involved in its construction and that Jewish slaves captured during the siege of Jerusalem provided much of the labor. The Pont du Gard aqueduct in southern France bears inscriptions identifying the engineers responsible for its construction. Roman engineering pride wasn't just about building impressive structures, it was about making sure everyone knew who built them and how they did it. Yet when we examine the megalithic foundation at Baalbek, this pattern of documentation simply disappears. There are no Roman inscriptions claiming credit for quarrying, transporting, or positioning the massive stones that form the base of the temple platform. No engineering treatises describing the innovative techniques that would have been necessary to move blocks weighing 1,000 tons. No emperors boasting about accomplishing what would have been the single most impressive engineering feat in Roman history. The documentary silence is complete. What we do have documentation for are the Roman temples themselves. Inscriptions confirm that various emperors contributed to the construction and embellishment of the Temple of Jupiter and the surrounding complex. But these inscriptions specifically refer to the temples, the columns, and the decorative elements. They don't mention the foundation. It's as if the Romans simply accepted that massive platform as already existing, something to build upon rather than something to create. This brings us back to the foundation itself and what makes it so distinct from typical Roman construction. The trilithon, those 3 enormous blocks in the western retaining wall, represent a level of megalithic construction that stands apart from anything else the Romans built anywhere in their empire. Each block, measuring roughly 19 meters in length, represents approximately 700 to 1,000 cubic meters of solid limestone. The specific gravity of limestone means each cubic meter weighs between 2.3 and 2.7 metric tons. Even using conservative estimates, we're looking at stones that individually weigh more than 800 tons. To understand just how extraordinary this is, consider that the largest stones the Romans typically worked with in other construction projects weighed between 5 and 15 tons. These were substantial blocks, certainly, and moving them required careful planning and significant labor. But they were within the normal range of what Roman engineering techniques could handle. The trilithon blocks aren't just heavier than normal Roman stones, they're exponentially heavier, representing an entirely different category of construction. Professor Daniel Lohmann from the German Archaeological Institute conducted extensive studies of the Baalbek site over several years. His team used modern surveying equipment to measure and document the foundation stones with precision. What they found was remarkable in multiple ways. First, the sheer size of the stones exceeded what historical records suggested was possible with documented ancient technology. Second, and perhaps more importantly, the way these stones were fitted together demonstrated a level of precision that seemed inconsistent with the tools supposedly available. The joints between the trilithon blocks show tolerances measured in fractions of a millimeter. Modern stonemasons, using diamond-tipped cutting equipment and laser measuring tools, would consider such precision a mark of high-quality work. Yet these stones were allegedly cut and fitted using bronze or iron chisels and hand tools. The surfaces where the stones meet are so precisely matched that capillary action prevents even water from penetrating the joints. This isn't just impressive stonework. It's stonework that pushes against the boundaries of what we understand about ancient capabilities. Dr. Jean-Pierre Adam, who has studied Roman construction techniques throughout the Mediterranean region for over 3 decades, visited Baalbek specifically to examine the foundation stones. His assessment was direct and troubling for those who assume Roman origin. The cutting techniques visible on these stones don't match the characteristic patterns left by Roman stoneworking methods. When Roman masons cut limestone, they left specific types of tool marks that archaeologists can recognize. These marks come from the systematic use of point chisels and tooth chisels, tools that leave distinctive patterns on stone surfaces. The trilithon blocks show different patterns. The faces of the stones are remarkably smooth, suggesting either extensive finishing work that would have taken extraordinary amounts of time, or possibly different cutting methods altogether. Researchers have noted that the surfaces show characteristics consistent with abrasive cutting, perhaps using sand and water in combination with some kind of saw mechanism. The problem is that while the Romans did use saws for cutting smaller stones, we have no evidence they possessed saw technology capable of working on blocks of this size. Another aspect that distinguishes these foundation stones from typical Roman work is their positioning. The trilithon blocks sit approximately 7 meters above ground level, positioned as part of the retaining wall structure. Getting stones of this weight to that height would have required either massive earthen ramps or an extremely sophisticated lifting mechanism. Roman engineers did use cranes, and we have good documentation of their capabilities. The largest Roman cranes, based on descriptions and archaeological evidence, could lift loads of around 10 to 20 tons using systems of pulleys and human-powered tread wheels. Lifting an 800-ton block would require something entirely different. Some engineers have calculated that it would take somewhere between 40 and 80 cranes working in perfect synchronization, assuming Roman-era crane technology could even be scaled up to handle such loads. The coordination required would be immense. Any imbalance in the lifting process could cause catastrophic failure, potentially destroying years of work in seconds. And yet 3 of these stones were successfully lifted and positioned with such precision that their joints remain tight after more than 2,000 years. The evidence keeps pointing toward a conclusion that makes many archaeologists uncomfortable. Either the Romans possessed construction capabilities far beyond what any surviving documentation suggests, or the megalithic foundation predates their arrival at the site. The second option would explain the absence of Roman records. You can't document building something you didn't actually build. It would explain why the construction techniques don't match Roman patterns found elsewhere. And it would explain why the scale seems so unnecessary for the temples that were eventually built on top of it. The Romans may have simply discovered an existing platform and recognized it as an ideal foundation for their temple complex, building their own structures using their own well-documented techniques on top of something they neither created nor fully understood. In 2014, a team of archaeologists from the German Archaeological Institute and the Lebanese Directorate General of Antiquities were conducting routine excavations near the ancient quarry site located approximately 800 meters from the main temple complex at Baalbek. The team, led by Dr. Jeanine Abdul-Masih, was working to better understand the stone extraction methods used at the site. Their ground-penetrating radar had indicated something substantial beneath the surface, but nobody was prepared for what they were about to uncover. The excavation began normally enough. The team cleared away layers of soil and debris that had accumulated over centuries, but as they dug deeper, their equipment kept encountering solid limestone. They expanded the excavation area, following the edges of what they were uncovering. Hours turned into days, and the stone just kept going. When they finally mapped out the full dimensions of what they had found, the entire team stood in stunned silence. They were looking at a single, precisely cut limestone block that measured over 19 meters in length, approximately 4.5 meters wide, and roughly 4.5 meters high. The calculations were almost difficult to believe. Based on the dimensions and the density of the local limestone, this single block weighed an estimated 1,650 metric tons. To put that in perspective, that's heavier than 3 fully loaded Boeing 747 aircraft placed on top of each other. It's heavier than the entire metal framework of the Statue of Liberty, and it represents more stone mass than anything humans have documented moving in all of recorded history. What made this discovery even more remarkable was the state of the stone itself. This wasn't a rough chunk of limestone left behind because it cracked or proved unsuitable. The block had been carefully cut on 5 sides, with smooth faces showing clear evidence of systematic quarrying work. The 6th side remained attached to the bedrock, suggesting that the extraction process had been deliberately halted before completion. Everything about the stone indicated it had been prepared for transport. Someone had invested considerable time and effort into cutting this massive block free from the surrounding rock, and then, for reasons unknown, the project was abandoned. But this 1,650-ton block wasn't the only abandoned megalith at the quarry. Nearby sat what archaeologists call the Stone of the Pregnant Woman, another enormous limestone block that had been quarried but never moved. This stone weighs approximately 1,000 tons and has been visible at the site for centuries. Local legends had grown up around it, giving it its distinctive name, but its origins remained mysterious. The 2014 discovery suggested it wasn't an isolated case of an abandoned stone, but rather part of a larger pattern. Further investigation of the quarry revealed yet another massive stone, even larger than the first, partially buried beneath the 2014 discovery. The quarry site essentially contained 3 enormous megalithic blocks, all cut with precision, all prepared for transport, and all abandoned in various stages of extraction. This raised immediate questions about what had happened. Ancient quarrying was expensive and labor-intensive work. Stonecutters didn't invest months or possibly years of work into preparing blocks this size without serious intention to use them. The abandoned stones suggested that whoever was doing this work had a specific plan. They needed stones of extraordinary size, they had the technical capability to cut them free from the bedrock, and they presumably had some method in mind for transporting them to the temple site and incorporating them into the existing structure. The trilithon blocks already in place at the foundation proved that moving stones of this size was within their capabilities, at least at some point. So what changed? What could cause such an abrupt halt to the work? Some researchers have suggested natural disasters, perhaps earthquakes that damaged the infrastructure needed for transport. Others have proposed political upheaval or military conflicts that might have disrupted the workforce. But none of these explanations quite fit the evidence. The stones weren't damaged or vandalized. They weren't half-finished in a way that suggested rushed abandonment. They simply stopped being worked on, left in place for thousands of years until modern archaeologists began investigating the site systematically. The question of how these stones could have been moved has occupied engineers and archaeologists for decades. To understand the challenge, it helps to look at what modern technology can achieve. The largest mobile cranes operating today have maximum lifting capacities around 1,000 to 1,200 metric tons under absolutely perfect conditions. These machines are engineering marvels featuring counterweights, hydraulic systems, and sophisticated computer controls to manage the immense forces involved. They require carefully prepared, perfectly flat, reinforced ground to operate safely. Even slight ground irregularities can cause catastrophic failure when dealing with loads of this magnitude. The terrain between the Baalbek quarry and the temple site is rocky and uneven, dropping in elevation in some places and rising in others. There are no paved roads, no prepared surfaces that could support extreme weight. The ancient builders would have been working with Bronze Age or Iron Age technology at best. No steel cables, no hydraulic systems, no computer guidance. They would have relied on rope, wood, bronze tools, and human or animal labor. Various theories have been proposed for how this might have been accomplished. The most common suggestion involves wooden rollers, typically imagined as large logs placed underneath the stone, allowing it to roll forward as workers pulled from the front and pushed from behind. This method has been successfully used to move stones weighing several tons, and there's good archaeological evidence for its use in various ancient cultures. But scaling this technique up to handle 800 or 1,000-ton loads presents enormous problems. The first issue is material strength. Wood, even dense hardwood, has a compressive strength limit. An 800-ton stone resting on wooden rollers would generate pressures that would crush and splinter most wood types almost immediately. You couldn't just use larger logs. The forces involved would overwhelm the wood's structural capacity regardless of size. Some engineers have suggested using multiple parallel rollers to distribute the weight, but calculations show you'd need dozens of rollers working simultaneously, and they'd need constant replacement as they failed under the load. Even if you solved the roller problem, you'd face the challenge of providing enough pulling force. Estimates vary depending on terrain and friction assumptions, but most calculations suggest you'd need somewhere between 10,000 and 40,000 people pulling in coordinated effort to move an 800-ton stone using rope and roller systems. That's not just a large workforce, that's a small city worth of laborers all working in perfect synchronization. The rope technology alone would be formidable. You'd need cables thick enough to handle the load without snapping, and they'd need to be anchored to something capable of withstanding enormous tensile forces. The communication and coordination required staggers the imagination. How do you direct 10,000 people to pull at exactly the right moment with exactly the right force? Ancient construction projects certainly employed large workforces. The pyramids of Egypt were built by thousands of workers operating in organized teams. But those projects had the advantage of relatively flat terrain and stones that, while heavy, were manageable with documented ancient techniques. The Baalbek stones represent an entirely different category of challenge. Then there's the matter of lifting these stones once they reach the temple site. The trilithon blocks sit approximately 7 meters above ground level, positioned as part of the retaining wall. Getting an 800-ton stone from ground level to that height would require either massive earthen ramps or an exceptionally sophisticated lifting mechanism. Earthen ramps are possible, certainly. The Egyptians used them extensively. But a ramp capable of supporting an 800-ton load would itself be a major construction project, requiring careful engineering to prevent collapse. And once the stone was in position, that ramp would need to be dismantled, leaving no trace. The alternative lifting mechanism would need to be even more impressive. Some researchers have proposed massive wooden cranes or lever systems, but the forces involved make these proposals highly speculative. Modern structural engineers who've examined the problem generally conclude that moving and lifting stones of this size with documented ancient technology borders on impossible. Not theoretically impossible, perhaps, but so improbable and difficult that it raises serious questions about whether our understanding of ancient capabilities might be incomplete. Dr. Erhard Kepler, a German engineer who specializes in ancient construction techniques, spent several months at Baalbek examining the tool marks visible on the foundation stones. His findings added another layer to the mystery. The cutting patterns on the megalithic blocks don't match the typical signatures left by Roman stoneworking tools. Roman masons used specific types of chisels that leave characteristic marks on limestone surfaces. These marks appear throughout the Roman world, from North Africa to Britain, creating a recognizable pattern that archaeologists can identify. The Baalbek foundation stones show different patterns entirely. The surfaces are remarkably smooth, lacking the pitting and roughness you'd expect from chisel work. Some areas show what appear to be saw marks, suggesting that sections of the stone were cut using some kind of blade technology. The Romans did use saws for stone cutting, but typically for much smaller blocks and often for decorative work. There's no evidence they possessed saws capable of cutting through multiple meters of solid limestone, yet the marks are there, suggesting techniques we don't fully understand. Lebanon sits on one of the most geologically active regions in the Mediterranean. The Dead Sea transform fault system runs through the country, making earthquakes a recurring threat that has shaped the region's history for millennia. Major seismic events have struck the Bekaa Valley repeatedly over the centuries, with historical records documenting devastating earthquakes in 1759, 1837, and several other occasions throughout recorded history. These weren't minor tremors. They were powerful earthquakes that toppled buildings, collapsed structures, and fundamentally altered the landscape. The Roman structures at Baalbek bear witness to this seismic violence. Of the original 54 columns that once stood in the Temple of Jupiter, only 6 remain upright today. The rest have fallen over the centuries, victims of earthquakes that repeatedly shook the foundations of the temple complex. The columns that do remain standing require modern stabilization work to keep them from toppling. Archaeological. Excavations around the site have uncovered fragments of columns, capitals, and architectural elements scattered across the ground, testament to the destructive power of the earthquakes that have hit the region. Yet throughout all of this seismic activity, spanning more than 2,000 years, the megalithic foundation beneath the Roman temples hasn't budged. Not a single one of those massive stones has shifted, cracked, or moved out of position. The trilithon blocks remain exactly where they were placed, their joints still tight, their positioning still precise. While the structures built on top of them have fallen multiple times, the foundation itself has remained completely stable. This stability puzzled modern engineers who began studying the site with advanced technology. In recent years, researchers have employed 3-dimensional laser scanning to create detailed digital models of the foundation stones. These scans can measure features down to fractions of a millimeter, revealing details invisible to the naked eye. What they discovered was remarkable. The stones aren't simply stacked on top of each other like children's building blocks. They're part of a sophisticated interlocking system that allows for controlled movement during seismic events. The joints between the massive blocks incorporate what modern engineers call seismic isolation principles. Instead of being rigidly fixed in place, the stones can shift very slightly in relation to each other when the ground moves. This micro-movement absorbs seismic energy that would otherwise cause structural failure. When the shaking stops, the stones settle back into their original positions. It's a principle that modern earthquake engineering didn't formally recognize and incorporate into building codes until the late 20th century. Yet it's built into a foundation that's at least 2,000 years old, possibly much older. The implications of this are significant. Seismic engineering requires understanding how earthquake waves propagate through structures, how different materials respond to dynamic loading, and how to design joints and connections that can accommodate movement without failure. Modern engineers spend years studying these principles using computer modeling and laboratory testing. The ancient builders of the Baalbek foundations somehow incorporated these concepts into their design without any of the analytical tools we consider essential today. This has led some researchers to reconsider their assumptions about when this foundation was actually built and by whom. The evidence increasingly points toward a possibility that makes many archaeologists uncomfortable. The megalithic platform might predate the Roman presence at the site by a considerable margin. It might even predate any civilization we have clear historical records of in the region. Archaeological investigations have established that human habitation at Baalbek extends back at least 9,000 years. That's 7,000 years before the first Roman soldier set foot in what they called Syria Phoenicia. Various cultures occupied the site over millennia. The Phoenicians considered it sacred, naming it Baalbek after their god Baal. The name itself survives to this day, suggesting the importance this location held in Phoenician religious practice. When the Greeks arrived, they renamed it Heliopolis, the city of the sun, incorporating it into their own religious framework. The Romans, following their typical pattern of adopting and adapting a local sacred sites, built their massive temple complex dedicated to Jupiter. Each of these civilizations recognized something special about this location. They didn't choose it randomly. There was something about this specific spot in the Bekaa Valley that drew religious and cultural significance across multiple cultures spanning thousands of years. Perhaps they were all responding to the same thing: the presence of an already existing foundation whose origins had been lost to time, but whose obvious importance and impressive scale demanded recognition. Recent ground-penetrating radar surveys of the site have revealed that the visible foundation stones might only be part of a much larger structure. The surveys indicate additional layers of megalithic construction extending beneath the currently visible stones. The platform continues deeper underground than anyone previously realized. There may be entire sections of the foundation still buried, hidden under centuries of accumulated soil and debris. Current funding limitations prevent extensive excavation, so these deeper structures remain unexplored, their extent and characteristics unknown. The weathering patterns on the visible foundation stones provide another clue about their age. Stone exposed to the elements develops characteristic erosion patterns over time. The rate of weathering depends on the type of stone, local climate conditions, and exposure to wind and rain. Geologists can estimate the age of worked stone surfaces by examining these weathering patterns, though the technique provides rough estimates rather than precise dates. When researchers examined the foundation stones at Baalbek, they found weathering patterns suggesting exposure to the elements for significantly longer than the Roman structures built on top of them. This brings us back to the fundamental mystery that no one has adequately solved. The scale of this foundation is wildly disproportionate to any known temple structure from any civilization in the region. The Romans built impressive temples throughout their empire, but none required foundation stones weighing 1,000 tons each. The Greeks built the Parthenon, one of the most celebrated temples of antiquity, using stones that maxed out around 10 tons. The Egyptians built temples that lasted thousands of years using stones of manageable size. Every ancient civilization, we have good documentation for built structures, scaled appropriately to their needs and capabilities. Baalbek breaks this pattern completely. The foundation there is overbuilt to an almost absurd degree. It's like discovering someone built a bridge capable of holding 10,000 tons in a location where nothing heavier than a horse cart would ever cross. The engineering is impressive, certainly, but it raises immediate questions about purpose. Why invest the enormous effort required to quarry, transport, and position stones of this size if smaller stones would serve the same structural purpose? Some researchers now propose a scenario that sounds speculative until you examine the physical evidence carefully. An unknown civilization, possibly operating during the Bronze Age or even earlier, built this foundation using technology and techniques that were subsequently lost. This civilization possessed engineering knowledge that exceeded what we typically attribute to ancient cultures. Their society might have collapsed catastrophically, perhaps due to war, disease, climate change, or some combination of factors. The knowledge they possessed disappeared with them. Centuries or even millennia later, subsequent civilizations discovered this platform already in place. They recognized it as an ideal foundation for their own sacred structures and built upon it without understanding or being able to replicate the original construction methods. The Romans found it, admired it, and used it as the base for their temple complex. They never claimed credit for building it because they didn't build it. They couldn't have built it with the techniques they documented and used elsewhere throughout their empire. This theory would explain several puzzling aspects of the site. It would explain why there are no Roman records documenting the foundation's construction. It would explain why the construction techniques don't match Roman patterns found at other sites. It would explain the disproportionate scale, which might have made sense for whatever the original builders intended but was unnecessary for Roman temple purposes. And it would explain the advanced seismic engineering, which represents knowledge that took modern civilization thousands of years to rediscover. The engineering sophistication visible at Baalbek exceeds the documented capabilities of every ancient culture we know operated in the region. The construction was abandoned abruptly, with precision-cut stones left in the quarry, as if workers simply stopped mid-project and never returned. The seismic isolation principles built into the foundation weren't formally understood by modern engineering until the 20th century, and the sheer scale remains wildly disproportionate to any documented human construction needed from any known ancient civilization. The evidence compounds when you examine it systematically. We have massive stones that modern cranes struggle to lift. We have joints fitted with tolerances that challenge modern manufacturing capabilities. We have seismic engineering that anticipates knowledge humanity wouldn't formally develop for thousands of years. We have construction techniques that don't match any documented ancient culture in the region. We have a complete absence of contemporary records explaining how or why this was built. And we have weathering patterns suggesting the foundation is significantly older than the structures sitting on top of it. You can visit Baalbek yourself and verify these facts firsthand. You can touch these stones with your own hands and feel the smooth surfaces that suggest cutting techniques we don't fully understand. You can examine the joints between blocks and try, unsuccessfully, to fit paper between them. You can stand beneath 1,000-ton blocks suspended 7 meters in the air and contemplate the engineering required to place them there. The mystery isn't hidden or speculative. It's physically present, measurable, and verified by every expert who studies it. The question that emerges from all of this isn't simply how they moved these stones, though that remains deeply puzzling. The real question is what they were building. What structure could possibly require a foundation built from the largest worked stones in human history? What purpose demands engineering sophisticated enough to survive millennia of earthquakes? What were the original builders planning that required such massive, precisely fitted blocks? And perhaps most unsettling of all, what happened to them? Where did this knowledge go? If a civilization possessed technology capable of accomplishing what we see at Baalbek, why don't we find evidence of similar construction elsewhere? What catastrophe or historical circumstance caused such advanced engineering knowledge to disappear so completely that subsequent civilizations couldn't replicate it? These questions remain unanswered. The stones at Baalbek stand as silent testimony to capabilities we don't fully understand, built for purposes we can only guess, at by people whose identity remains lost to history.